Hello, everyone. Welcome back. Today, we're going to continue where we left off. Last time, we were talking about combinations. So, we're going to continue talking about combinations. There's one more example here that we didn't quite get to last time, which was example four. And so, I'd like to do example four right now because I do feel it's a good, important example that has a lot of insight to it. So, let's go ahead and do that. Example 4 says, in a math class of 20 people, consisting of 12 males and 8 females, 10 students will be chosen to represent the school in a math team competition. In how many ways can the team be chosen if there are no restrictions? So this one's pretty simple. Basically, there's 20 students and 10 can be chosen, and it doesn't matter who. It doesn't matter whether they're males, females, whatever. Just there's 20 people, we're choosing 10 people is all. Okay, so we're going to plug that in our calculator. 20 and then the NCR button on the calculator, and then 10, then hit the equal sign, and we get 184 756. Okay, the next one says an equal number of males and females are chosen. So in this case, it's not an equal proportion of them both, it's just an equal number, right? So if we're choosing a team of 10 and we want an equal number of males and an equal number of females, that means we must have 5 males chosen and 5 females chosen. So of course there's going to be less combinations here than there were before, because in this case we only care about the combinations where males and females are equally represented and shown here. We don't care about times when there's either more males than females or more females than males. And probably most of these cases have a bit of a discrepancy. Probably most of these cases we either have slightly more males or slightly more females in the group, right? It's not that likely that we would get exactly an even number of both of them. So let's see. Let's do this one. So the number of ways in this case would be, let's see. Well, we have 12 males, and we want to choose exactly 5 of those males. And then we have 8 females, and we want to choose 5 of the females. So let's punch those both in. 12 choose 5 gives us 792. And then 8 choose 5 is 56. So that's 44,352. So that's far less than the 184 because, again, most of these combinations from earlier are going to have more of one gender than the other, most likely. Good. All right, let's try C. C says at least 7 females are chosen. Okay. So basically, if 7 females are chosen or more, there's only 2 ways to make that happen. Either there's exactly 7 females chosen, or there's 8 females chosen, because keep in mind, there's only 8 females in the class. Okay? So basically, the number of ways in this case would be equal to exactly 7 females plus the number of ways for exactly 8 females, right? Because in this case, we're asked about at least 7 females. So that means 7 or more, and the only way to get 7 or more is 7 or 8 because 8's our maximum. So keep that in mind. Okay, so in this case, let's do that. We know that it's going to be 8 choose 7, right? Because there's 8 females. We're choosing 7 of those 8, so only one is not coming on this case. And then the remaining 3 seats, right? Because we're choosing 10 people in all, or be males. So we're going to be choosing 3 males from the 12, right? Then in this next one, exactly 8 females. We're going to choose all 8 females. So 8 choose 8, which is really just one way, right? There's only one way of choosing all 8 females. And then the other 2 spots must be 2 male students because there's still 2 spots left. So 12 choose 2. Then we're going to say equals what? Well, this is going to be equal to 8 times, let's see, 220 plus one way, right, times 166 ways to choose the 2 males. So that's going to be 1,760 plus 66, which is equal to 1,826. So there's really not a lot of ways to make this happen in comparison to the larger number because there's so many other options, right? There could be 6 or 5 or 4 or 3 or 2 or 1 or 0 females chosen, right? And so all of those are going to add up to a lot more of the ways than just these very, very specific restrictions where it has to be 7 or it has to be 8. Good. Now, how about this one? This one is going to be a lot more likely. This one says, how many ways are at least 2 females chosen? So in this case, we could do it one of 2 ways. We could do it the direct way, which would be where we'd have to figure out how many ways exactly 2 are chosen, exactly 3, exactly 4, exactly 5, exactly 6, exactly 7, and exactly 8. And I don't want to do that. That seems like too much work, and mathematicians are lazy. Well, it's not that. It's that it's always best to find the path of least resistance, and that's not to say that it's best to take shortcuts or you know, or to not do a very good job. However, when there is an easier way to accomplish the same goal, I I suggest always taking it. So we're going to do it that way, which is the indirect way, which is where we're going to take the total number of ways to, without any restrictions to make this committee. And then we're going to subtract off the ways we don't want. So we're going to subtract the ways where there's no females chosen and also subtract off the ways where there's only one female chosen, because that is the path of least resistance, right? So we're not cutting corners here exactly. We're just choosing an option of a way to solve this that's going to give us just as valid an answer, that's going to result in the same answer for doing less work. So that's what we're going to do. So in this case, the total number of ways for at least 2 females is going to be the total ways in all, the total ways with no restrictions, minus the ways for no females chosen, so an all male committee, minus the number of ways of only one female chosen, so we'll say exactly one female chosen, and the other 9 people would have to be males. So it's not very likely that there's no females chosen or only one, so we're expecting this number, this answer, to not be equal to 184, 756, but to be very, very close to that. Because, how likely is it that, there's not going to be any females or there's only going to be exactly one? There's a lot more ways for there to be 2 or 3 or 4 or 5 or 6 or 7 and 8 females. Okay. So total number of ways with no restrictions, that was 184, 756. So I'm just going to copy that from up there. Then how many ways are there for no females to be chosen? Well, that would mean an all male team. There are 8 males, or sorry, there are 12 males, and um, we're going to choose all 10 of those males to be on the team. Or wait, how many people were on the team? Yes, 10 people are on this team. Good. So it's going to be 12 choose 10 in this case because we're only choosing males, we're not choosing females. And then we're going to subtract again. Let's see. A scenario where we only chose one female, right? So if we only choose one female, that would be what? That would be 8 choose 1, right? We're only choosing one female times the rest of the team must be male, right? So 12 choose 9, right? We're choosing the other 9 people to be males. Okay, so now we're going to grab our calculator and calculate that. Let's find out what 12 choose 10 is equal to. 12 choose 10 is equal to 66. So 184, 756 minus 66. And then minus 8 choose 1 we know is 8. And then what's 12 choose 9, I wonder? That is going to be 220. Okay, so let's see. Then 8 times 220 is 1,760. So if we do the whole subtraction there, we're going to end up with 1,760, 182,930, like that. Good. All right. So there's our answer. So as you saw, that's most of the people, right? That's most of the different ways that there are of doing this committee, right? That's most of the different ways taken care of there. Very good. Very, very good. All right, well, that is it for combinations, part 2. Next time, we'll talk about binomial theorem. And binomial theorem, by the way, is actually the last topic of this unit. So we're very close to the finish line here. So good work today, everyone. I will see you next day for binomial theorem. Bye, everyone.